Yes, viewers, good morning. How are you doing? I hope you're fine. Members, welcome back to our Math in Motion channel, YouTube channel. Members, before we begin, I want to encourage you to subscribe, like, and comment for the videos. I think now you can begin up. Today, we're going to talk about what we call matrix partitioning. Yes, talk about matrix partitioning. Yes, today we want to see how we can partition a matrix. Given a bigger matrix, just see how we can partition a matrix, and then this will help us to find the determinant of a matrix of a bigger matrix, of a big size matrix. An example, we may have e.g., we may have a matrix in this format. Our matrix A can be a bigger matrix, which is a 3 by 3, which is now we may have a 2 here, a 3, a 4, then a 3, a 2, then a 3, a 4, then a 3, and then a 4. As you see, this matrix is a 3 by 3 matrix, but now we can partition this matrix into a simpler a 2 by 2 matrix by us making it a partition. Like I mean that we can transform this matrix A to become a 2 by 2 matrix by having A11, A12, and then A21, and then A22. Like we can divide this matrix to become this matrix. Now, for us to do this, we shall use what we call the Hussey's result. Yes, I'm saying we shall use the Hussey's result. The Hussey's result tells us that if we want to partition a matrix, if we have a big matrix like this one, and we want to make it a partition into a smaller matrix, which is a 2 by 2 matrix, what we need to do is to make sure that this matrix A11 and A22 are square matrices. That's what we need to show. Only. That's what we need to put into considerations. Now, what should we do now? An example, we have this matrix here. We just need to divide this matrix into two 4 sections, and we make sure that matrix A11 and A22 are square matrices. How do we do that? Now, for example, in this case, we have a 3 by 3 matrix. In order for us to have a 2 by 2, like a square matrix here, a square matrix is either 1 by 1, 2 by 2, 3 by 3. This is what we call a square matrix. These are square matrices. That's what we call a square matrix. Now, from here, this is an example of ours. In order for us to find, in order for us to divide this matrix into form a square matrix, just need to see that A11 and A22 is form square matrix. We can divide it like this. By us dividing like this, we shall have our A11 to be a 2, which is a 1 by 1 matrix. What is going to be our A22 is going to be 2, 3, 3, and 4, which is a 2 by 2 matrix. Now, what's going to be our A12? A12 is going to be 3 and 4, which is 3 and 4, which is a row by column, it is a 1 by 2. And then what is going to be our 1? Our 1, 2, 1 is going to be 3 and 4, a 2 by 1 matrix. I think with that, we are able to partition our matrix to form this following the following matrix. And then we can also have an example, a simpler example of a 4 by 4 matrix to see how we use now the Hussey's result to find the determinant of the matrix. Okay, an example. Now let us first have this. I think for this you are able to appreciate. I'm saying in order for you to partition a matrix, you have to make sure that A11 and A22 form square matrices, and therefore for any matrix you are given, make sure that A11 and A22 are square matrices. Like in this example of ours, I have a 2, I have a 2 by 2, so here I have a 1 by 1, here I have a 2 by 2. That's my A11 and A22 are square matrices. Therefore, after us transforming this after us partitioning a matrix into this, we can always now find the determinant of a matrix A. We find the determinant of matrix A using this formula. Determinant of A11 times the determinant of A22, yes, minus A21, yes, times A11 inverse times A12, determinant of the whole of this thing, given if the determinant of A11 is not equal to 0. Or if it is equal to 0, our determinant of A is going to be determinant of A 2 times determinant of A 1, yes, minus A 1 times the inverse of A 1, inverse of A 2 times the matrix of now of A 1, like that. Yes. Are we okay on that point? Yes, we are okay on that point. If we are the determinant of the whole of this thing, if the determinant of A 2 is not equal to 0. Members, I think that is the formula we have to use in order for us to get the determinant of a given matrix which is big. Remember, first to find the determinant of a 3 by 3, a 4 by 4 matrix, we go in the fields of cofactor matrix. Now, this is a shorter method that will enable us find the determinant of a matrix, a bigger matrix, using the process result. Members, allow me to take you quickly through an example. Yes, one example to see how we apply this method on a given question or a matrix. Okay, members, let's input of this. Yes, allow me input of this. We just need to now to recall those formulas in our mind, but I'm going to give you a simple trick on how to recall them. We may be given a matrix A. Given our matrix A equals to it has have now a 4 by 4. I have 10, I have 6, 4, 5. Then you have a 5, then you have a 3, then you have a 5, then you have a 1 here, then you have -2, then you have 2, then you have 12, then you have 3, then you have 0, then you have 1, then you have 3, and then you have 8. Let us take an example. Now this is our question. Now they want us to find the determinant of A. Question is saying find the determinant of A. Now for us to find the determinant of A, if we try to go in for cofactor matrix, it's going to be a longer process. We can just choose to use our matrix partitioning and then use the process result to see how we can get the determinant of a matrix. Now from here, we can partition our matrix in the form that we have our A11, A22 to be a square matrix. We say we can also turn this equation by matrix partition. It has to be in the format A11, A22, A11, A12, then A21, and then A22, such that A11 and A22 are square matrices. Like now, for a case here to make 1, and 2 square matrices, we shall just need to divide this matrix of ours in this way. How? I just need to divide our matrices in this way. With ease, I just get to know that if I put like this in the middle, I'll be able to get my A11, A12, A21, and A22. I'm saying that my A11 is going to be 10, 5, 6, and then 3. Yes. That's just my A12. My A1 is going to be -2, 0, 2, and the 1. Yes. Then what's going to be my A21 is going to be 4, 5, 5, and then 1. Yes. And then what's going to be my A22 is going to be 12, 3, 3, and then 8. Now, from these members, I think we can appreciate that we finally transformed our matrix, which was big, into a simpler matrix, which is this one. I'm saying note that we have to have A11 and A22 to be square matrices, and then we have a 2 by 2 and a 2 by 2 here. Kati, what we need to do is just use any method we want. We say that we shall always find the determinant of the matrix using the Hussey's result, saying that the determinant of A equals to determinant of A11 times the determinant of A22, yes, minus determinant of A21 times the inverse of A11, yes, times A12, determinant of the whole of this, if determinant of A11 is not equal to 0, or we use that our determinant, or determinant of A11 equals to determinant of A22, yes, times determinant of A11, yes, minus A now 1, 2 times the inverse of A22 times A. Now we shall have 1, 2, 1 if determinant of A22 is not equal to 0. We can choose to use any method we want. Now, a trick of recalling this formula is just that we see the difference is just only on this point here. You see, if I begin with A11, my inverse here has to have A11. But inside here I have to have A22, and then these two has to be the first here, and then these two has to be the end here. Well, you are seeing where I can easily come the formula from. That if I have A11 here, here I have the inverse of A11, but now this is going to be A22. Therefore, I have to begin with a 2 and then end with a 2. Therefore, I have to have determinant of A22 minus determinant of A21 times the inverse 1, 1 times now times 1, 2. I think members are getting the trick there. Also here, likewise, if I begin with A22 here I have A11, then I'll have the inverse of A22 here because I have the A22 here. Then I'll begin with 1 and then end with 1. Then I have 1, 2, then I have 2, 1 here. I think and that could be easier to recall. Now, members, allow me to find the determinant of this matrix using this formula. For me, I'm going to employ formula 2. You can also use formula 1, provided the determinant of this matrix is not 0. Now, for us here, we just let us use determinant of A11. Yes, let us use. I personally, I prefer using. Let me just use the second definition. Yes, let me put off this first and write it again properly. Like we are saying, I'm saying we are going to employ this formula that our determinant of matrix A equals to determinant of matrix A 2, 2 times determinant of matrix A11 minus determinant minus A 1, 2 times A 2, 2 inverse, yes, times A. Remember we have a 2 here. Therefore, I have so I have a 1, 1 here. I have to end with 1, 2, 1. Now, what do we need from there? We just need to find the determinant of A22. What's the determinant of A22? It is how you get the determinant of a matrix. This is my A22. It is major diagonal minus minor diagonal. Like I multiply major diagonal minus minor diagonal. I have now 12. This is the same as having 12 times 8 minus 3 times 3. And it's going to be 87. The answer. Therefore, my determinant is going to be 87. Yes. Are we together? Now, my other task now is finding now the inverse of this A22, because I need to use it here. Now the inverse A22, the inverse, the inverse is the same as having 1 over adjoint. So 1 over determinant times adjoint. 1 out of determinant. The other determinant is 87 times adjoint. Adjoint, just for a 2 by 2 matrix, just interchange, then change signs. I'll have negative 12 here, then I'll have a 3. Sorry, I am saying I interchange. This one comes here, then I change signs here. Then I'll have 8. Yes, I have a 12 here. Now signs here change. Negative 3, negative 3. Something like that. Now from there, therefore my inverse is going to be something good. I'm going to have now 8 over 87. Yes, I have now negative 3 over 87, and then negative 3 over 87, and then 12 over 87 as my inverse. Now, after getting my inverse, now my next case is I need just to find out this value here. Because I need to have this value, I have it by A11, then I get down the determinant of the whole thing. Now let me first find. I'm finding now. I'm finding what? Let me use a different marker because we have resources. Remember, and thank you for helping the channel. I'm saying we are now finding A22. So A11 times the inverse of A22. Yes, times now A21. What is A12? A12 is negative 2. Yes, negative 2, 0, 2, 1. like this one here, times the inverse. The inverse is this from here. We have 8 over 87, negative 3 over 87, and then negative 3 over 87, and then 12 over 87. Then now times again, the A21 is this, 4551. Yes, 4551. 4, 5, yes, 5, and then 1. Now, members, as we know that this is a simpler case, we can multiply using a calculator or multiply using row by column, as we know. But members, I urge you to first get this answer you got here, because we have a time constraint. Take your time and get this answer. We have to get negative 34 over 87, then negative 74 over 87, and then 82 over 87, and then 71 over 87. Members, this is the answer we get here. You can press calculator and get matrix A times matrix B times matrix C and get the answer here, or maybe choose to go slow by slow and you go by a column and get the answer. Now our step is now is subtracting the A11. Then you need to get A11 minus the answer I've got here. It is A12 inverse of 22, and then A21. Now get the answer here. We just have subtraction. A11, it is 10. Here 5, then 6, then 3. Yes, here. Now minus the answer we have, which is this one, minus negative 34 over 87, like this, and then negative 74 over 87, and then we have 82, have 82 over 87, and then we have 71 over 87, like this. Now we subtract the entries. 10 minus this, 5 minus this minus this, and this minus this. Now what do we get from there? After subtracting, we shall get some matrix as the answer of here. If you try to get properly the answer, it's going to be 904 over 87. Yes. Then we shall have 509 over 87. Yes. And then we shall also have 440 over 87. And lastly, we shall have 109 over 87. I'm saying if you subtract now, 3 minus 71 over 87 shall have this value here. And then this is our answer here now. Our answer of the whole of this. Now what we need to know, what we need? Now we need to get the determinant of the whole of this now. And then multiply times the determinant of this. Yes, members. Let me take off this and then finalize with our answer. Now I'm saying that what we need is now getting the determinant of this part here. Members, we have our determinant of A equals to, the determinant of A22 is 87. Yes. Now times the determinant of the whole of this, which is this determinant of matrix. We have 904 over 87. Then you have here you have 509 over 87. Then here we have 440 over 87, and then 190 over 87. Now, if this is the determinant. How do you get the determinant? You just get major diagonal time. We have major diagonal minus the minor diagonal. Now, after multiplying 104 and 904 over 87 times 190 out of 87, we get negative 200, and then you subtract, you shall have 87 into times. Now this multiplication times. If you multiply and then subtract, you shall have negative 200 out of 29. And then lastly, we get our answer as negative 600. And then this could be a simpler way of finding the determinant of a matrix using partitioning. Members, I think for this video, it is short and precise, but I think you have enjoyed. What I'm asking you, friends, is to just keep on doing other examples. The major takeaway here is that we need to, first of all, partition our matrix in a format that A11 and A22 are square matrices. That's the first thing. The second thing is first to note the formula for finding the determinant, i.e., that determinant of A equals to A22, determinant of A22 times determinant of the whole of A11 minus A12 times the inverse of A22 times A21 From there, we shall be able to find the determinant of a matrix as we have done. Members, try out some other questions, things I want to be fine. For any questions, just feel free to comment, to answer questions in the comment section. I'll be able to answer. Thank you for watching. This is Math in Motion and the second audio math tutor. Members, thank you for watching. Thank you for the help. Thank you for the subscribing. I just urge you to keep subscribing and watching these videos. And then members, try to like the videos because we feel not well that we can have more views than likes, which is not fine. Thank you, members. I am Shakan, your math tutor. I sign out.